This video contains step-by-step instructions for applying Hess's law. Recall from the last lesson that reverse reactions will have the opposite sign for enthalpy change. If coefficients are multiplied by a factor, so too must the enthalpy change. This is because the amount of energy absorbed or released is proportional to the amounts of chemicals involved. In most Hess's law problems, you will typically be given a chemical reaction equation and be asked to determine the enthalpy change for the reaction. This reaction is what you will be working towards as you begin to combine other reactions. In this example, you are given 3 different balanced equations to work with and their corresponding enthalpy changes. Start to look for commonalities between the products and reactants in the reaction you are working towards and the 3 reactions you have been given. There is only one reaction that has carbon in it, so you know that you will need to use that reaction for sure. In the reaction that you are working towards, there are 3 of those carbons in the balanced equation, so you will want to multiply this balanced equation by 3. Notice that when each term is multiplied by 3, the enthalpy is also multiplied by 3. Another of the given reactions does contain propane, C3H8, but it is shown on the reactant side, and we will want it on the product side because that is where it is shown in the final reaction. To reverse the reaction, we will switch the products with their reactants and change the sign for the enthalpy change. At this point, it is a good idea to combine what you have so far so you can get an idea of what else needs to be added. When these 2 reactions are combined, the reactants go on the reactant side, the products go on the product side, and the enthalpies are added. Anything that is the same on both sides is canceled out. Compare this new reaction to the reaction that you are working towards. You will see that there is oxygen and water in the balanced equation that is not in the reaction that we are working towards. By adding the other given reaction multiplied by 4, you are able to cancel out these entities and are left with the final reaction that you are working towards. Ultimately, you will end up with a reaction that you are working towards and an enthalpy change for that reaction. The strategy for Hess's law is something of a trial and error process. The secret is to pick a product or reactant that is common between the given reactions and the reaction you are working towards, and begin combining. As long as what you end up with, in the end, is the balanced equation that you are working towards, and you have followed the rules for reversing reactions and factors, your enthalpy change calculation should be correct. Here is a summary of the steps involved in determining enthalpy changes by using Hess's law. Begin by writing the net reaction equation. Then manipulate the given equations so that they will yield the net equation. Multiply, divide, or reverse the sign of the enthalpy reaction. Cancel and add remaining reactants and products to yield the net equation. Then add the component enthalpy changes to obtain the net enthalpy change. For a final step, determine the molar enthalpy for a reactant or product if required. Please complete the September 18th quiz.